organization. What lies beyond DMEC? These experiments we have done only concern animals. So this is only, to try and understand the cellular components. This is a female 76-year-old patient. These are her conditions. I intervene in the right eye to tell you that intraoperative OCT is very important, also to examine cells, and also endothelial microscopy when it is accessible, and also the positioning of the flap. So what is the most important limitation currently affecting DMEC? High failure rate or allogenic rejection, or surgical complexity with a very steep learning curve, or optical aberrations? In your opinion, I'm asking the audience. Correct. That was my opinion too. So, what can we do in order to improve functional results? There is a learning curve. So how can we improve functional results? How can we avoid reintervention? There are techniques to isolate human corneal cells as an alternative to keratoplasty are being explored. Anyway, in animals, in vitro cultures, we have realized there is a certain proliferation. It is limited in the case of humans, and it is a very expensive technique, as Nicola was saying. So we consider the stem cells as an alternative to corneal endothelial replacement and regeneration. My experience is only based on mesenchymal stem cells harvested from the bone marrow. Of course, you might take them from fatty tissue, from hair tissue, etc. Mesenchymal stem cells can be easily retrieved from several tissues, and the patient can be both donor and recipient at the same time, provided that you can rely on these cells. So with this tissue engineering, it is possible to graft tissues from the same patient, from the patient himself. There are some differences between endothelial cells and mesenchymal stem cells, but mesenchymal cells can proliferate, and you can read these references to papers on animal, laboratory animal studies, and look at the migration potential of mesenchymal stem cells. This is in rats, and these cells survive and migrate in the iridocorneal angle and ciliary processes, and then a level of the anterior capsule. So future perspectives. We are talking, let's repeat that we're talking about animal studies, we can try and introduce a layer of mesenchymal stem cells without removing corneal endothelium. And another perspective is this one. We want to use the exosomes derived from MSCs that merged with the lysosomes of the damaged corneal cells that can induce a block of apoptosis and regeneration. Let me repeat that we are only working on animals. These are animal studies. So in order to reduce the number of donors that can then be used for other things, we have to remember that these are autologous grafts. So we are still at the level of at the beginning of our experience in a way. We have to see the differentiation procedure for MSCs and endothelial cells, and we should also study how to administer these cells. Clinical trials on humans can only start in the future. We are still at the beginning of our study. And anyway, in the future, maybe there can be autologous grafts. So thank you for your attention. I try to make my speech